Hello and welcome to this tutorial in which we're going to learn how to build an interactive intelligent remote control for Senza. Now, the remote control that works with Bluetooth that ships in the box with your cloud connector has got a couple buttons on it, up, down, left, right, OK, back, home, and content hub. We're going to make an emulator that runs on an iPhone in a little web app that has the same functionality as that remote control. So if you lose it, you can substitute your phone instead. But in addition to that, it's also got a trackpad, so you can send gestures. It's got a way that you can type, and it's got a way that you can send voice commands. So you're going to get 4 for the price of 1. So let's start with a little quick demo. As you can see, the app on my screen running on Senza's got a little QR code. So I'm going to zap that with my physical device. Now I'm actually going to use the iPhone simulator on the screen just so that you can see what I'm doing, but rest assured I've got exactly the same thing on my phone and it works the same way. So our app is very simple. It's got a soccer ball, otherwise known as a football, here on the screen. And our use case is very simple. I can use the arrow buttons to move it around. So as you can see, what's happening is that I am literally taking the JavaScript event handling system that you're already familiar with. If I hit the up button on the screen, for example, you'll notice that it's sending an event just as if I was using a regular browser and I hit a key on my keyboard. The Bluetooth remote control is going to send an event through the Senza infrastructure that my app is going to receive as a key down event. So what I'm actually going to do is I'm going to use a very similar paradigm where when I hit one of these buttons here, I'm going to be sending an event using Socket.io, not through the Senza infrastructure, but directly to the web app, which will receive it, but process it in a very similar way. So the way the app works in terms of the buttons is I can use the buttons to move the ball around. And you can see in the console here the messages that I'm receiving. I can hit the button in the middle, OK, to move the ball back to the middle. Like that, and so forth and so on. Now, in addition to that, I've got a little trackpad here. So if I make some gestures here, I can actually move the ball around on the screen, and you can see exactly what's happening. So that gives me a lot more freedom than I have with the arrow keys alone. If I want to be able to send text, I can use my phone's built-in keyboard, which I'm already very fluent at using. So I can say, for example, and let me turn on the on-screen keyboard so you can see what I'm doing. So I can say this is a soccer ball. So that gives me the experience of being able to type directly into Senza if that's the way that I want to interact with the app. But the nice thing about it is that I can use the on-screen keyboard that I'm very familiar with, and I can type really fast on that. So that's much better than an on-screen keyboard. I can use the back button to clear the text. And for my final trick, we don't actually have access to the content hub through a software API. So I'm going to hijack that button and I'm just going to record something. Anti-disestablishmentarianism is my command. And as you can see, it displays the text right there on the screen. I can go ahead and clear it. It also recognizes known voice commands like center. So you can more or less give it commands and tell it what to do in addition to using speech input. So that's a demo right there. Let's go ahead and have a look at some of the source code for how that is implemented. So as I said, we're using a Socket.io server. The server is extremely simple in what it does. All it does is forward commands. So you'll notice that when the app running on the TV first connects, it sends a join message. And we call this function called socket.join, which effectively has it join a chat room with a device ID that we create on the web page on the fly. Then, for any one of these events, for example, mouse down, mouse move and key down are the ones that we care the most about. We are essentially going to receive that event. So when we receive it, we're going to log it to the console, and then we are going to emit it to the device whose device ID is in the message. So as you can see, this is basically the entire server program for forwarding the events. So let's go ahead and have a look at how the app on the TV screen is implemented. It's really quite simple. It's got a QR code in a white rectangle. It's got that little soccer ball or football, and it's got a little text field that shows up if you want to display some text. Fun fact, most of this program was written with ChatGPT. I was kind of lazy. I didn't feel like writing code, so I just leaned back and told it what to do and then had a chat about how to evolve it. So pretty amazing what you can do with generative AI these days. You'll notice we're not actually using the Senza client library. I'm creating a unique UUID to use as the device ID on the fly, and I'm caching it so it'll always use the same value. Now the reason I'm doing that is just so that I can run this app either in Senza or outside of Senza, but still have the benefit of having this be pretty secure. When we start up the app, we're going to connect to the server by sending that device ID, calling the join message, as you saw right here. That's the one that handles that. And we're going to generate a QR code that points to the other web page, which is called remote.html and has the device ID in the query parameters. So when I zap that QR code, that's where it's going to go. And what we have here are a couple of listeners so that this actually works. There's a web version of this. If you do have a mouse, you can actually just drag the ball around directly. Of course, you can't do that on Senza. That's why we're making remote control. The most important function that we respond to here is this mouse move function, which essentially gets the movement X and movement Y properties from the event, calculates the new location that it should be moved to on the screen. It constrains it so it stops at the edges, and then it updates the style properties to move the ball around. We have some functions that respond to up, down, left, right by moving a certain number of like n pixels in any given direction. We also have some handlers for key events. So you saw, in this case, up, down, left, right, do those things. And we also respond to certain commands. So when I speak a command like center or left, it'll actually go ahead and do that as well. So that's how that works. Let's go ahead and have a look at the code for implementing the remote app. It has a text field. It's got a little rectangle that we use as the trackpad. And it's got a picture of the remote control with an image map that calls a couple of functions. So you can just see up, down, left, right are the functions that it calls. Looking at the code itself, we're going to connect to Socket.io, and then we're going to grab that device ID from the query parameters in the URL. All the messages that we're going to send to the server are chaining through this one function called send message. It's going to add the device as a parameter to the message, log it to the console, and then send it to the server to be forwarded to the Senza app. So as I said, we are handling 4 use cases. We are handling mouse, touch, keyboard, and voice. So if I were to run this client app on my computer, it will work. I can actually use the pointer to drag around. So you'll see that when I'm running this client app in a computer web browser using a mouse, it responds to these functions. We only want mouse move to work when we are in a drag. When we are just hovering, we don't want it to do anything. So the mouse down function sets a flag to indicate that the mouse is down, and the mouse up function sets a flag to indicate that it is no longer in a click. We send these functions to the server and we forward them, but we're not actually using these for anything right now. These send the absolute coordinates of the mouse down and the mouse up. For the move, what we're going to do is, if we are in a mouse down or we're using a touch interface and we have some non-zero movement, then we are going to send a mouse move message. Now, in order to avoid flooding the server, we are going to debounce these. That means that if we get multiple calls to this API, to this function, which fires very fast within 20 milliseconds, just a short amount of time, we're going to coalesce them by adding them all up before we send them. So this send message function is basically just going to send movement X and movement Y to the server. So as you see, if I go in here and I drag around, then we'll see every time this called, every 20 milliseconds, I moved a couple of pixels, and that's what gets the smooth animation on the screen when I'm doing this. So the important thing is we've got some listeners. So when we get the event, we call the function with the equivalent name. Now let's go ahead and look at how we do it with touch. It's pretty similar, but we get some different functions. We get touch start, touch move, and touch end. And what's different is because the multi-touch interface can have multiple places on the screen where you are touching it at the same time, we get an array of touches. So we're going to use the first element in the array. And when we call touch move, we are going to manually calculate the difference between the previous call to that touch. So we're going to have a variable that calls the previous touch. When the touches start, we are going to reset it. That prevents us from having touch events that are big jumps from the last place that we touched the screen. So we're going to calculate movement X and movement Y to basically emulate how it works with a mouse. And then we're going to chain to the mouse move function. So we're listening to touch start, touch move, and touch end, and that's pretty much all we need. So for the keyboard, you noticed that when you type into the field here, it just sends whatever keys you are typing. So we have a function here called sendKey that just sends a message with the event's key. We're going to listen to anything happening in that text field and call sendKey. We're also going to send special keys like the arrow keys whenever I use the up, down, left, right. This is really going to be emulating, just like the Bluetooth remote emulates a keyboard where you are typing arrow keys. This is going to do almost exactly the same thing, except instead of sending it via Bluetooth to the cloud connector and then via the Senza infrastructure to the app, which receives it as a key event, we're going to do the same thing using Socket.io. by sending keys like arrow left. And then, as you remember, when we receive that, we have a listener where, just like we have a typical key down that receives events, we're going to use the same function with socket.io, unmodified, exactly the same one to handle our key events. So in this case, we have that image map right here that calls those functions. Those functions each call send key, and that's it. If you've seen our previous tutorial on speech recognition, we've just copied the code right here. This is a much shortened version of it. We are hijacking that button that's normally for the Content Hub to be able to send voice commands. Note you need to press it to start recording and then press it to stop, and when you stop, it's going to send the command. So when it gets a result and it's final, it's just going to go ahead and send a message, which is essentially whatever text it recognized. And that's about it. So let's get this code out of here, and we can drag our football around a little bit more. We can say, that's pretty cool. And I can clear that. That is pretty cool. And that's it. Thanks for watching. Hope you enjoyed.